as you can see, it is similar to previous one.
In the sense that?
In general, like the minimum temperature is less in the countryside, and in the city it is higher because of buildings and stuff like this.
Yeah, and if you compare the range of change for this extreme cold temperatures, let's say, compared to how the extreme warm temperatures are changing, do you see something, or can you?
I don't know really. I think that it is the same, like the cold temperature became higher, will become higher as the cold.
Yeah, so if here you have a change of about, let's say, if we look at 2100, let's take that one, around 7 degrees increase of your mean daily temperature. What is that if we go back to the mean daily max temperature? I think that's one of your first, I think one or two slides back. I thought you also had one on the temperatures. No, it might be. The max temperature is not included in this one. Yeah, it doesn't matter too much. But what you could expect in this case, and that would be also interesting, so if you add the graph on the change of the mean annual and the annual maximum temperature, now what you could expect in this case for Helsinki, because you have a cold climate, then you'll see, that's what I expect to see at least, higher increases of your minimum temperatures compared to the increases of your maximum temperatures, or at least compared to your average temperatures. So that you will get a shift, but it's not an equal. If we look at the distribution of temperatures today, it's not an equal shift, but you might also see a change in your distribution. So that's what you could relate also here, is look into how in its obviously how the change in your mean daily minimum temperature compares to the change in your annual mean, annual max, summer max temperatures, and where that's less for and how that's related. So that's an interesting one in your case to take up. I'm also not completely sure for the one on the right. It might be interesting, but I'm not sure if you'll get it out. How it's changed also compared to this one. So now you're looking at the absolute map on the right. Might also be of interest in your case to see how the changes differ across the region and how that is different for the rural area and for the urban area. Might be interesting in this case.
And here we see some suggestions about the climate conscious design. The climate of St. Petersburg is very continental to marine. The region is characterized by frequent change in air masses, largely due to cyclones activity in some westerly and northwestly winds prevail, and in winter westerly and southwesterly. So the main suggestions is to use passive solar energy, to use south-facing west windows, and to use the high thermal mass materials to build the buildings to save the warmth inside the building and keep it cold in the summer season. And as well, maybe use green roofs to make the temperature in summer season water in the city center because there's quite lack of green spaces. And here's recommendations for built environment of my case study. So the main suggestion is to use wind management and protection, wind breaks and sheltering because it is very high speed of the wind and it is not comfortable for people to go outside in the winter season, and, but no, not from the winter, but from the autumn until spring. So it is the half of the year, then you can just feel comfortable outside. And water and storm management, as we have very heavy rains and high humidity, it is essential to collect water and maybe to reuse it. And this is reflection of the impact of the St. Petersburg itself, the city center. It is suggestion to design buildings with the south orientation, use a wind protection as well because it is also very windy inside the city. Retrofit thermal efficiency and thermal bridges, use water drainage and green water infrastructure, and the use of our renewable energy sources to heat the buildings in the cold weather because now it is not sustainable in the city. Yeah, that is all.
I had one question only about the greening and green roofs in the city. What was not completely clear for me is how densely built is the city.
Yeah. It is very denser, but for instance, now we construct a lot of buildings. We have, for instance, spaces, and we not going to use it like green pockets or something. We use it to build new housing. And if it is city center, it is always like very expensive housing. So I understand that we will not change the attitude towards city center, but at least we can use these green roofs to make it better.
And would it be an effective measure in that area?
I think so, because it is very denser in the city center because of the historical buildings, and the surface is became very hot in the summer season, so the temperature difference between countryside and city center can be 5 degrees difference. So if they will going to use green roofs, maybe these surfaces will not heat as like usual roofs. And as well, these green roofs can help with water storming system, like they will absorb some water, rainwater in it.
Depending on the type of green roof you would put, because you can have a green roof with a buildup of about a meter, then you have some capacity to store. If you have other types, then it's way less package, let's say, that comes on top of the roof. So then that would be rather limited in impact or in water storage. I'm not completely sure whether green roofs would be for this type of, if for sure in city center, if it would be the most effective measure. There are other aspects of course as well. And also, as you say, it's a historical city, how feasible it would be to implement these. That might also be in something, if that would be a strategy to implement in St. Petersburg, to look at is it even feasible if you have a lot of pitched roofs with historical buildings.
Yeah.
Then you will be quite limited. So that might be a reason to look at different options.
But we have this typical courtyard, so the block of the buildings, and the rest of the building you just don't see from the street. So maybe if it is shifted from the street, it can be implemented in this case.
There might be possibilities in that. One more question that I had is so you had your case study. How would it differ, because your case study is, from what I understood, located in suburbs?
Yeah.
How would you adapt the building differently, or the environment around the building differently when it's placed in the suburbs, or when it would be more located in the city center?
If we're talking about suburbs, it will be more useful to make this water collection maybe reservoirs to reuse this water, and to also to situate where maybe some wind, I don't remember the name,
Windbreaker?
Yeah, not breakers, but wind which is producing energy.
Windmill.
Yeah.
A windmill?
Yeah.
That's the right English word.
Something like this, yeah. Because it is possible to do it in the countryside, and as well there is a lot of examples in Estonia and in Finland, but we haven't got this in Russia, as we don't use sustainable types of energy. And as about city center, it will be more about not such global measures, but small implementation of solar panels and also wind shelters. I don't know.
How would those wind shelters, because I think that's an interesting in this case, differ in how you would implement them in a city center, where you have other boundary conditions, let's say, compared to how you would do it in the suburbs?
I think in the suburbs it can be like a system of these shelters or something like this, where you have, for instance, village, and like in Canada, they have this system of shelters because they have very extreme cold, and they're using it in the winter to connect the buildings, housing, with the main public used buildings. So maybe it will be something like this, but in case of city center, it will be something different, because we have system of streets, and in one street it can be a high wind, and in another it can be no wind at all because of the system of the street. So about city center, I don't really know.
Yeah, you would have to more look in building layout, and then of course it's an existing city. So then, like the example we saw in Tokyo, and then the train station area, if they would have new developments, they could see then how they could improve breaking the wind in that case, or how they could align things. So that would be something in the city that you could take into account if you would have a redevelopment of an area within the city center to improve, or perhaps it's already done in good way, so that's something to take into account. Any other ideas, questions, remarks? I thought that someone had the case of Canada. I don't recall who exactly that was, but had the city of Montreal. How do you relate to what has been? Are there things that you have implemented in a similar way, like with the windbreakers, or?
I also have some recommendation that quite similar to Netherlands case, such as triple glazed window green roof system, shading system. We can use overhangs and some shades.
Did you look into measures for the wind, or is that less of an issue in Italy?
I didn't look into it.
And would that be of interest for your region or for your city? Yeah. No, would it be of interest? That's the.
The heat stress.
The heat stress is the main issue you need to tackle, which is less of a case in so that would mean, because now I have to think in north south that they're quite on the line. So I would expect that it's quite similar. It's not,
I think in the
because here heat stress is not really an issue.
I think it's similar to Belgium, but in Belgium there is no such cold weather in the winter.
Yeah.
But in general, here is more humid and less windy. But to compare it, it is a little bit similar.
And to compare to Montreal,
Montreal is ranked among the most deadly city for heat wave.
okay. Good. Then I suggest, thanks for your presentation, that we move further to Ankara and yeah, go ahead. No one will. We continue with the presentation, and I will pronounce your name.
Doğa.
No?
Yes.
Okay. Oh.
Hello, I'm Doğa, and I'm going to present my case study and analysis. So my case study is located in Ankara, and it's a typical old Ankara house. And these Ankara houses are generally 2 or 3 story buildings and with courtyards. And this is one of them with like 120 meter square floor area. These graphs shows the annual absolute change in mean air temperature in Ankara and daily maximum air temperature in Ankara.
How does it in your case compare with the global changes?
This shows the, as you said, the best and worst case. Then it is like increasing through the years. So there should be, and we should be do something to compensate this.
Yeah. But how, if you look at how the curves are going in the case of Ankara, and if you compare it to the global mean temperature indications, does temperature change faster or increase faster in Ankara compared to what is happening globally, or is it blind, or is it slower?
I think it's going like a little bit faster.
Yeah, so if you look at the 2 degree is a good one to check it. So if you have your annual mean temperature and you have it, I should use this one. Yeah. So we have it at 2 degrees. Well, faster, quite aligned, I would say, in this case. So you kind of see changes in line with, of course, in the worst case scenario. And it might slow down a bit. It's hard to see at this point. So it's quite aligned actually with what you see happening globally.
And here is the absolute change in maximum air temperature that divide. Yes, the maximum air temperature in Ankara and the summer. Maximum air temperature. Absolute change in daily maximum air temperature. I can say.
So in here you can actually see, and it's might be a bit misleading, but if you look to your y-axis for the daily max temperature in summer, then well, it goes up to 10. While if you look at the annual daily max temperature overall, then we have an increase of at max 67 a bit. So you see that in the summer daily max temperatures are changing more extreme than your annual, which makes sense because you have your warmer temperatures in summer, and you see an increase there that is higher. So you get a bit of a redistribution also of your temperatures. So that's also something to look at, so that you don't have an equal change across the whole year, but that the extreme events become more extreme. That's actually what you also see here, and what is of interest. Also, if you would see that we have a change of, and let's look at 2050, and you have an increase of your summer daily max temperature with about 4.5 degrees, and I'm not sure, so your baseline is 28 degrees for the reference period. That means that you have daily max temperatures in summer going up to 32 degrees, so that's something that you would, we have quite some input. So that's the kind of things that you can also get out of these graphs. You of course see that they will increase. I'm afraid we won't see graphs today that show a decrease in temperature, but it's more than only it's increasing. It's how does it compare to global changes? What do you see in how annual temperatures change compared to max, compared to min temperatures, and what could that mean for the location you are looking at?
Okay. And for the precipitation graph and the relative humidity graph, I can say it's not going really faster to the reference of like the global mean. Is it okay? Is it correct?
It's hard to say based on this one, because actually here on this graph, and that's different with the temperature, the annual mean temperature graph, you see, so what it actually shows you here is that in a world where we are 2.5 degrees warmer, there you could expect a decrease of your precipitation by, let's say, approximately 10%, which is not nothing. You have quite high reductions. Okay, they're uncertain, but they're quite high. So that's how you can interpret these results. In this case, you cannot see whether it goes faster or slow, because in that case you would need to see also the curve of the precipitation change globally. That's a bit harder to see here, but you can see that in a 2.5 degree warming world you would have this reduction, and that's where it happens for you. It's around 2055, something like. Then you align actually with a 2.5 degree warming world in the change of precipitation. If you see these, so you have a drier climate in the future, are there already problems with droughts in the region?
I think yes, it will be a drier. In the future it will be more dry.
And And is that already today causing problems?
Yes, because today is also sometimes we have like problems about the no rains and dry weather. So
And-
it will be more like a problem.
And if you look at the precipitation pattern today, if there are already issues of drought, do you have little rain across the year, or are there periods with very intense rainfall?
It's like it sometimes rains. There are like periods, like in winter generally it rains or snow, and in September, October, that period, rather than in summers we don't have rain generally.
So if rather very dry periods and more wetter periods, it's a periodic thing. So what could you expect if you see that you have a further decrease in precipitation? How might it be causing issues, or would there be further issues?
I think these seasons, these periods may change according to that. Like they can be a little bit shortened, or I think so.
Yeah, you might indeed see a shorter wet period, a longer dry period. You might also expect, if it's raining, that some events will be more extreme. And what you can then, so you have an overall drying of the region actually. If you have sometimes more intense, or if at all rain falls, it might cause more issues because your soil is so dry that it's way harder to absorb water, which might lead here. I think if you would look into, I'm not sure if they're included, but if you would go for an impact indicator that is looking into flooding or damage, or looks at agriculture impacts, that there you might see a high impact related to the decrease in precipitation. Might and also for your urban environment, if it rains and your soil is not able of absorbing water, you get flooding, so that might be causing issues in that case.
And actually, I couldn't find the data for Ankara, and that was just from Turkey. There was Istanbul, so it continued with Istanbul.
How different is Istanbul from Ankara?
Actually, it's more humid because it's near the seaside, and a little bit warm, I must say. And here it shows the heat stress change, high heat strength changing during the days.
And you're looking at which scenario here, 2020 climate
Yes.
policy? So also put the other one, the shifting pathways, next to it, because then you will see the spreads you will get. And that's a general comment. I also saw a remark. I also saw in other presentations that sometimes only one scenario is added. Add both so that you see the range and you get an idea of the spread. And also add so the 2020 climate policy scenario and then the shifting pathway scenario. I'll show a slide on the end that's listing those again. Because then what I would expect here is if we would see a map of Istanbul in the shifting pathway scenario, then you would see you would see lower, a little bit lower changes, not necessarily that much lower. But for sure, here on this graph, your shifting pathway scenario would be somewhere, let's say, you would guess around 3-4 in this case. So that would show you a big range. Similar here, if you have quite a spatial pattern in your map, try to just explain what is causing that. So how the urban environment, but also rural, urban is explaining this pattern.
I think Istanbul is really a crowded city, and they have the urbanization is really much. So this affected how we see these more orange, reddish color there. It was, I think, because of that. There are many settlements there. Yeah. And the light changes in light, changes in nights a year with minimum temperature about 20 degrees in Istanbul from 2020s, and it's not actually in Ankara it is much more than Istanbul, I may say. But Istanbul, because of the maybe humidity, is it because that there are not much really changes there.
Might wind be helping here?
The wind?
Yeah, I can't imagine if I'm not sure. Could imagine if you have a more wind, well, though if it's coming from the south, then it's typically a warmer wind. But I could imagine that you're close to the sea, that somehow a sea breeze might help and flow through the city. What I'm actually very curious about is you have certain regions here that are have way higher increases. I don't know if that might be linked to the orography, soil type, or what's going on. It might be. It's interesting to see actually. It might also be, and in that case it might be of interest, but if we would look at the absolute numbers for this map,